We are reviewing these special characteristics about the absolute value function. We learned this way back at the very beginning of the first 6 weeks. We learned the name of the parent functions. The name of this function is the absolute value function. This is the equation, the y equals the absolute value of x. We learned that the absolute value function looks like the graph of a V. The parent function has an origin or a vertex right there at the origin, 0, 0. It has a slope on the right side with a positive 1. The slope on the left side is a negative 1. We can understand the creation of that if we look at a table of values. You can pick any x values that you want and plug them into the equation, and the equation is the absolute value of x. So if I plug in -2 into this, the absolute value of -2 is +2. The absolute value of -1 is +1. That's why we're getting, when we graph these functions up here, when we graph this -2, 2, we go to -2 and then we go up because the absolute value of -2 is +2, and so there's the point -2, 2. Continue on the table. Each table, and you really should memorize a few points. The points that I would memorize for this table are going to be these 3 right here. And the reason that these 3 are helpful to memorize is because if you know those 3 points, it's this point right here, this point right here, and this point right here. When we start transforming them, which is what's happening in just a minute, see, we're doing transformations, you'll always kind of have an idea of how those 3 points are transformed. But again, review the domain for any absolute value function is always going to be all real numbers. That means that we're going to begin the x values at -infinity. Remember, here's the x-axis. The x-axis is the horizontal axis. And since the x-axis is horizontal, we read our domain from left to right, so we're starting way back here at -infinity, and then it's going to contain every x value until we get all the way to the far right side, and the far right side then is the positive infinity. So that's why we say the domain is -infinity to positive infinity. The range, and this is true for every absolute value function. You could also, of course, just explain or write out that the domain is all real numbers. All real numbers. And that doubled bar R is actually, I'm not even being accurate with that. You could spell out the words all real numbers. Okay, you could write that out as a phrase, or you could use that symbol right there, which stands for all real numbers. Okay, so any one of those would be a way to describe the domain. And remember, I'm going to put a little asterisk by this because this is true for all absolute value functions. Now, the range is going to change as we transform these absolute value functions. The range is going to change, and I'll give you that information when we look at transformations. But the range for this one, the range, because some absolute value graphs are going to open up like this one, some absolute value graphs are going to open down like this one. So the range is either going to be the lowest value, like it is right here, the lowest y value, or it's going to be the highest y value, like this upside down one over here. Either way, it's either going to be, since we read range from the bottom up, we read range from the bottom up, it's either going to be where we first contact a point with a y value or where we last contact a point with a y value. So either way, this one's going to be the first point that we contact that has a y value, and that y value right there at that point is 0. So that means my range starts at 0, and then it contains all the numbers along this part of the axis, because there's a 1, there's a 2, there's a 3, there's a 4. So it's all of these numbers that are headed that way. And what value is above, keeps going up on the y-axis, that's positive infinity. So my range starts at 0 and it continues until positive infinity. It is going to be a bracket because there is a solid point right there at the zero, at the y that equals 0 value, and infinity always gets a parentheses. If we're writing this in inequality notation, we would just simply say y are all the numbers that are greater than or equal to 0. So be sure you're comfortable with interval and inequality notation. X-intercepts, you're either going to have 0, 1, or 2 x-intercepts. So the three examples, if this is the x-axis, we might have an absolute value function that looks like that. That means that it's not going to cross the x-axis. We might have one that looks like our parent function that just touches the x-axis, and then we might have one that crosses the x-axis and touches it twice. So this particular one has an x-intercept at 0, 0, and that means its y-intercept is also at 0, 0, but the x-intercepts are going to change as we move these absolute value functions around. Remember, the way you find an x-intercept, is to plug in 0 for y. Be sure you understand what this notation that I just wrote, be sure you understand what that means. That means to find an x-intercept, you plug in 0 for y. If those words don't come to you when you look at that, then you need to write those words down right here. You would write to find x-intercept, and this is true for any function. To find x-intercept, plug in 0 for y and solve. Okay, so what notation do we write on the y-intercept? We do the same thing, except we put a 0 in the x place, and then we put a y right there. What does this tell you right here? To find a y-intercept, you plug in 0 for x. The maximum number of roots, that's what I was just talking about whenever I was telling you it might have no intercepts, it might have one intercept, might have two. That's what I was talking about. So the maximum number that it can have is 2. End behavior, for every absolute value function, the end behavior will be the same. Now, it means that they will either both be going to positive infinity, or it may mean that they're both going to negative infinity. So it depends on, you have to look at the picture and see. This parent function over here, both ends are pointing up. So remember, as we say on the left side, how do I say left? This right here is saying left as x is approaching negative. So as I'm going along the x-axis to negative infinity, that's the left side. On the left side, the function is going up. And on the right side, how do I say right side? I say x approaches positive infinity. The graph is also going up. So the end behavior, these two things right here, should be the same every time you have an absolute value function, whether it's both going up or both going down. If your absolute value function looks like this one, then these would both be negative. This is always going to be a continuous function because we're going to be able to draw the entire graph. We'll be able to graph the entire absolute value function without ever having to pick up our pencil.